Today, we're taking a really fascinating hands-on look directly at the source material for the Pioneer X Honix battery hydrometer. We're going to decode exactly how this relatively simple but honestly incredibly powerful tool works and how it can totally save you from unexpected power failures. By the end of this explainer, you're going to view battery maintenance in a completely new, perfectly clear light. So, let me ask you this. Is your 12-volt battery fully charged, or is it literally on the brink of death? We've all been there, right? You turn the key in the ignition, or you go check your off-grid solar setup after a long cloudy day, and nothing. Just a click or a completely blank screen. The frustration of a sudden power failure is just the worst. But what if I told you that batteries actually rarely just die out of nowhere? That usually give us warning signs, but those signs are totally hidden inside the chemistry of the battery itself. Well, today we're looking at the preventative solution that lets you see exactly what's happening under the hood. Okay, let's dive into this. Here is our roadmap for today. First, we'll meet the tool. Second, we'll cover quick and safe assembly. Third, we'll walk step by step through the testing procedure. And finally, we'll decode your battery charge results so you know exactly what your readings mean. Let's jump into Section 1, Meet Your Battery's Best Friend. Time to understand the tool itself. All right, meet the Pioneer X Honix battery hydrometer. It kind of looks like a giant turkey baster mixed with a middle school science experiment, doesn't it? If you look at it assembled next to its packaging, you'll see a large black rubber bulb at the top, a clear glass cylinder right in the middle, an internal floating gauge with these really distinct color bands, and a rubber nozzle at the very bottom. But listen, this isn't just some piece of plastic. This is a precision instrument designed to physically pull the fluid out of your battery and measure its exact chemical state. It's basically the master key to unlocking the secrets of your battery's health. Now, to really understand how that tool works, we need to know what it's actually measuring. And that brings us to specific gravity. Specific gravity is simply the ratio of the density of your battery's electrolyte to the density of pure water. Now, you might be wondering, why do we even care about that? Well, as a lead-acid battery discharges, the sulfuric acid in the electrolyte is absorbed straight into the lead plates, leaving mostly just water behind. So the fluid naturally becomes less dense. Then, when you charge it back up, the acid returns to the fluid, making it dense again. By measuring that exact density, the specific gravity, our hydrometer tells us the absolute, undeniable state of charge of the battery. And here is the absolute best part about having this in your maintenance toolkit. Chemistry is universal across flooded lead-acid batteries. That means whether you're working with a standard red automotive battery for your truck, a heavy-duty inverter battery backing up your house, or a massive bank of solar batteries keeping your cabin off the grid, this one simple tool works perfectly for all of them. It's just incredibly versatile. Moving right along to Section 2, Quick and Safe Hydrometer Assembly. Let's set up for success. Before we extract a single drop of acid, we need to establish some safety ground rules straight from the manufacturer's packaging. Look at these 3 key warnings. First up, fragile glass components. You absolutely cannot just toss this into the bottom of your toolbox. It will shatter. Second, this is 100% not intended for children. We are going to be handling highly corrosive sulfuric acid, folks. And third, it's designed for commercial use. That means it's a serious professional-grade diagnostic tool for people who want accurate data. But it definitely demands respect and careful handling. Okay, let's talk assembly. The manual actually gives us a genuinely genius yet super simple trick for putting this together. Check out the tip for the rubber nozzle. It says to just dip that portion in water for easy installation. Because the main tube is glass and the end piece is really tight rubber, if you try to force it on dry, that glass could easily break right in your hands. A little water gives it the perfect amount of slip. Also, you see those red arrows? You have to make sure the internal float meter is aligned with those arrows so it rests properly inside the chamber and can rise freely without, getting stuck upside down. All right, Section 3, Step-by-Step Testing Procedure. Time to take a little micro journey right alongside the battery electrolyte. I am going to guide you through the exact physical sequence here. Picture yourself out in the garage doing this. First, you squeeze that black rubber bulb to push all the air out, and then you insert the flexible tube straight down into the electrolyte fluid inside the battery hole. Step 2, release the bulb slowly. Don't let it just snap back. Let it draw the electrolyte up into the clear cylinder nice and smoothly. Third, keep an eye on that inner float. You want to make sure it actually lifts freely off the bottom. Fourth, hold the entire hydrometer perfectly straight up and down, completely vertical. The float should be bobbing in the liquid, not leaning against the glass sides. Fifth, look exactly at the fluid line and read the color or the number on the float. And finally, step 6, and this is absolutely crucial for safety, carefully squeeze the bulb to push every single drop of that electrolyte back into the battery cell before you move on to the next one. And this brilliantly illustrates exactly what we were just talking about. Take a really close look at this cutaway diagram. You can see the actual internal anatomy of the battery. Notice those gray vertical bars? Those are the lead plates, and the blue area is the electrolyte fluid surrounding them. You can visually see how the flexible tip of the hydrometer has to plunge deep enough into that blue fluid to suck it up past the cell opening. It perfectly shows the bulb squeezed, then released, drawing the fluid right up so the internal float can do its thing. It's basically a perfect visual representation of the chemistry lab happening right inside your battery. Let's zoom in on the real star of the show here, the internal floats. This is the Honex HXB float scale. Look closely at the markings through that clear glass. You'll see these really bright, distinct, colorful bands, red at the top, then green, yellow, blue, and another red section down at the bottom. And right alongside those colors are numeric markers ranging from 1100 all the way up to 1300. When the fluid lifts this float, the exact point where the surface of the battery fluid intersects this scale, well, that is your specific gravity reading. A dense, super healthy fluid will push that float higher up, but a weak, watery fluid, it's just going to let the float sink lower. Which brings us to section 4, decoding your battery charge results. Time to pull out the decoder ring and translate that visual data into hard numbers. Now, what's really fascinating about this slide is how incredibly narrow the voltage window of a 12-volt battery actually is. This depth of discharge, or DOD table, is essentially our decoder ring correlating battery capacity to exact voltage. When your hydrometer tells you your battery is completely full and healthy, look at the very top row. A 0% depth of discharge equals exactly 12.70 volts. But as you use the battery, 10%, 20%, 30%, look at how incrementally that voltage drops. 1258, 1246, down to 1220 at half capacity. The specific gravity you measure with your hydrometer directly corresponds to where your battery sits on this very specific table. Let's really pull out the most important contrast from that data, because we have to understand these two extremes. On one side, we have a perfectly healthy 0% depth of discharge battery resting comfortably at 1270 volts. On the other side, we have a fully discharged, essentially dead battery. And what is the voltage of a 12-volt battery when it's totally dead? Well, it's drastically lower for sure, but actually, it might not be as low as you intuitively guess. So the crucial point is this exact number right here, 11.90 volts. If you throw a multimeter on your battery and it reads 11.90 volts, or if your hydrometer float just sinks deep down into the bottom red danger zone, confirming a thoroughly depleted specific gravity, your battery is completely discharged. It's not just kind of low, it is empty. Leaving a lead-acid battery sitting in this 11.90 volt state causes rapid sulfation, which permanently damages those lead plates we saw earlier in the cutaway. Understanding this specific threshold is exactly how you prevent your expensive equipment from dying a premature death. So, we've covered the tool, the safe assembly, the specific steps to extract the fluid, and exactly how to decode the state of charge right down to the decimal point. You seriously no longer have to guess if your battery is healthy. You can literally prove it. So I'll leave you with this final thought. Now that you have the knowledge and you understand the tools, which battery are you going to test first? Is it the car out in the driveway, the backup inverter down in the basement, or maybe the solar setup in the backyard? Get out there, stay safe, and take total control of your power. Thank you so much for joining me on this explainer, and I will see you next time.